Okay. All right, just waiting to see if the stream has started. I think the stream has started. Welcome to Advent of Code Day 7. Yeah, let's dive right into it. Day 7. Here we go. All right, handy haversacks. Haversacks. Ooh, I wonder if we're gonna see haversign today. That might make sense with flights. You land at the regional airport in time for your next flight. In fact, it looks like you'll even have time to grab some food. Excellent. Airport food is always terrible. All flights are currently delayed due to issues in luggage processing. Due to recent aviation regulations, many rules, your puzzle input, are being enforced about bags and their contents. Okay, so it's going to be about baggage rules, it looks like. Bags must be color-coded and must contain specific quantities of other color-coded bags. Okay, apparently nobody responsible for these regulations considered how long they would take to enforce. Yeah. For example, okay, consider the following rules. Light red bags contain one bright white bag and 2 muted yellow bags. I wonder if these are must. Like, must a light red bag contain 3 bags? Or may? Is this must or may? I wonder. I don't know. Dark orange bags contain 3 bright white bags, 4 muted yellow bags. Bright white bags contain 1 shiny gold bag. Okay, faded blue, dark olive, vibrant plum. I like the color names. They're kind of fun. Faded blue bags contain no other bags. Oh, no other bags. Okay. Dotted black, faded blue, no other. Interesting. So no other. So if we're gonna need to parse this input, this is gonna be interesting. So there's like a number, some color, and then bag or bags, and then the one exception that would be no other bags. These rules specify the required contents for 9 bag types. In this example, every faded blue bag is empty. Faded blue is here, no other bags. Okay, every vibrant plum bag contains 11 bags, 5 faded blue bags, and 6 dotted black bags. So every vibrant plum contain 5 faded blue bags, 6 dotted black bags. So do these faded blue bags also contain, oh, then no other, dotted black, no other. Okay, if you have a shiny gold bag, if you wanted to carry it in at least one other bag, okay, so you can nest bags, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least 1 shiny gold bag? Interesting. So in the above rules, the following options would be available to you. A bright white bag, which can hold your shiny gold bag directly. A muted yellow bag, which is this one, shiny gold bag. A dark orange bag, which can hold a bright white and muted yellow bags, either of which can hold your shiny gold bag. Okay, so this is the nesting thing that we're talking about. So in this example, the number of bag colors that can eventually contain at least 1 shiny gold bag is 4. How many bag colors can eventually contain 1 shiny gold bag? The list of rules is quite long. Make sure you get all of it. Okay. This did not go the direction I thought it was going to go. I thought given haversacks, I don't know, maybe a haversack is like just a really common type of bag that I've never heard of. This might be a thing because I'm Canadian. I don't know. Is a haversack a thing? What is it, like a backpack? Yeah, I don't know. This is day 7. Oh, okay, that's why I'm confused. All right. So let's create our literate CoffeeScript file. We will dump in our markdown. Okay. And we've got our rules here. Let's just indent these and put equals. Oops. Whoops. These options are available to you. These are not parsable rules. It's just some plain text. Okay, let's see how that works markdown wise. Yeah, looks good. All right. So got our 3 sections as usual. We're gonna have our definitions. We'll need a heading of 2. We're gonna have tests, and we are going to have the section where we actually just run the code to get the answer. I don't know, maybe I could come up with better names for these sections. Okay, so I guess what we'll probably do is we'll start in the test section as usual. We'll grab log and assert. These need to be indented one more. Require assert. So how are we going to go about modeling this is the question. What we want to do is we want to say, hey, it's like we want to find how many bags can contain our bag. So what we've got is we've got a series of rules where we've got like okay, let's take this rule. Let's deconstruct this rule a little bit. So we got a light red bag contains 1 bright white bag. So we don't even really care, I don't think, how many bright white bags it can contain. So a light red bag can, and a muted yellow. So if we wanted to know, let's say light red, either of which can hold your shiny gold bag. So bright white bag can contain 1 shiny gold bag. So let's have this rule as well. Bright white bag and can contain a shiny gold. So if we want to know with our shiny gold what can contain it, it can be contained by a bright white, and because bright white is up here, it can also be contained by a light red. So kind of want to have a structure like this, sort of, or a virtual structure like this, because I don't think it would be practical to make necessarily this structure. But where we find the shiny gold bag, we find that its container is a bright white bag, so we write that down. We find its container is a light red bag, we write that down. Vice versa, we put all this into, or not vice versa, etc. And we put all this into a set of possible bags, and then we read out this, or the length of this set, I guess, is what they want. They want to know how many bags. So how are we going to model this, I guess, is the question. And I guess each one of these rules, it could be just an array. I mean, that would be possible. We could have an array, and then we could search for things with the array. I usually like putting stuff like this in classes, in class definitions, just because it gives us a natural place to put methods like, yeah, so let's give that a try. I find like classes, they can be a little bit overkill sometimes, but I find that how clear that they can make the code is often absolutely worth any overhead that you might have. Constructor. It also gives you a natural place to put like parsing rules. It keeps your code together. This is like the classic idea of object-oriented programming, was sort of like, oh, it'll give you this like atomic thing that you can attach all your stuff to, and then you'll know where to find it. So what are these going to have? They're going to have color, and they're going to have child colors, alt colors, or cargo. I don't know. Children, I guess, will be good enough for child colors. I'm using the American spelling here, just because computers. So let's see how far this gets us. So the idea is that we're going to have a rule like this. We're going to need to parse this rule. parse. I'm gonna make this a class method. Rule, rude. And this is like an example of a rule that we're going to be passing as. It's going to look like this, and we're going to need to parse it into the color, and then we're going to also have the contents. We're going to have sort of like what colors are within it. So let's figure that out. So rule. All right. All right, so we're gonna have word plus, then space, then bag, and then maybe an S. And it's always 2 words, I think, so we might be able to get away with that. So bags. So let's just light red, muted yellow. Yeah, okay, beautiful. It's always 2 words. Cool. So we're gonna have, so no space, no spaces, and then followed by a space, and we're gonna do that twice, and then we're gonna have bags. So let's see if this works. So this is going to be rule dot parse, no, not parse, match this, and let's log this down here. So right now we're just in our sort of like discovery mode. So rule equals that. Let's run it. Oh yeah, we should log that. Null. So it didn't like that. So a non-space plus followed by a space, and a non-space followed by a space. I guess, oh, the space should be outside that. Okay, let's try that. Light red bags, bright white bag. Okay, so so these are going to be matches equals that, and then log matches. Okay, so we've got the whole match, but what we really want to do is we want to exec these, I think. Is it exec? No, it's not rule.exec. How do we get our capture group set? Geez, I'm not remembering today. Let's take a look at the first match. And is this an actual match, or is this just a string? Let's find out. Type of. It's a string. All right, it's time to look up JavaScript regex rules again. Ripped regex. Also coffee. Flags global source sticky. No. Okay, so compile exec. So there is an exec. So it's the regex that you exec on other things. Is it match or match? Ooh, match all. What's this match all? Let's try match all. Undefined. No. Is this just not available in Node? Is this like fancy, or am I just using it wrong? That's the real question. So regex string match all regular expression. Yeah, because this looks like what I want right here. String match all. I guess, can I not use this in Node? Node.js 12. Yeah, I should be able to have this. Unless, I don't know if like when I run the code, I don't know if it uses the node version that I have set here. So but what's the difference between match and match all, really? Let's take a look at match. Console log match. Yeah, I mean that's regex that matches symbol match. String match regex, and then result dot group one. So this is match, roll match that group. No. Match.group is not a function. Oops. This is just giving me all the matches back. Am I doing something completely wrong? String, match, and then this regex. So a non-white space character repeated, followed by a white space character, followed by nons. But yeah, I mean, this is giving me these, but it's not giving me the capture groups. This method is called internally in string prototype match. All right, let's see, exec should give me what I need. All right, let's try it the other way. We'll try exec rule. Let's see what I get back. That's what I get. Okay, so the first match is what I care about here, light red, and then two. Oops, this should give me the second one. Undefined. In one bright white bag. Oh, I need to call exec on it again. That's why. I know in a previous day we did something about this. Was it day one? Line pattern. What were we doing here? Line match, line pattern. Yeah, and we were getting back. Oh, I see. It gives us back these. Okay, so it has to be in one shot. So exec is if it wants to be in multiple shots. I thought global would give us. Yeah. What if we did multiple of these? No, that's just weird. All right, let's look at the match array. I guess we'll just do exec. We'll just do exec a couple of times. And, I find this so awkward. Yeah, because like we can do exec a couple of times, right? My red bag. What was saying groups is not a function, and it was saying groups is undefined, which is super weird. Match. Is it test? Test just says, is it in there? It says match is not a function, yeah, because it's rule match. It's kind of upsetting that match isn't working, and I have no idea why. So I mean, like, match is giving me these. What we can do is we can just pull these out and then just take the take the colors out of them. In fact, we can get rid of that, and we can just, because it always says bag. So bag, yeah, okay. We can just have that as the color. I mean, that'll be basically the name, not the color. So name, and then child names. That'll be easier. So we're gonna have names equals that. And so we're gonna have name and then children. Let's copy script. There we go. Children equals that. Okay. So, and let's pass back name and children. Actually, we'll just tilde print. So rule dot parse, and we'll log that to see what we get out. So we're getting back, oh yeah, this is just giving us the return of that. So we actually want like a new at and name and then children. That's what we're going to return. So we've got a rule with a name and some children. Okay, so we're going to need rules. An array of rules, and we're going to need to parse the rules into this array of rules. I don't know if this necessarily belongs up there. We can put it right here. Rules, and we can say input, yeah, for line in input split, and what do we want? We want rule parse line. Here, we'll put it on the new line. And we'll say rules dot push. Okay, and then we can log rules when we're done. Okay, so we've got all of these rules, and we want to know. Oh yeah, we haven't accommodated for this no other bag yet. Children, yeah. Whoops. So we haven't accommodated for this no other bag. I guess what we can do is we can just remove no other bag from children. Yeah, I mean we could filter them out. Yeah, let's do that. Filter. Or for child and children, we can child equals child dot filter name, and then name isn't what is it? No other bag. No other bag. So let's see if what that does for us. That is child filter. Well, that's because that's not a string. So yeah, we just want to do children equals children filter. And then, so now we don't have no other bag. Okay, perfect. So this is, let's leave a note here is what we're doing. Remove no other bag. Not other bag, no other bag, since that is a placeholder for nothing. Okay, cool. So we've got our rules. Now what we want to do, we want a way to say that shiny gold bag can have this as a parent. We need to find the parents. So we want to find, may have multiple parents or multiple containers, and we're going to probably have to pass the rules in the rules array. And so what we're going to do is going to say rules or rule in rules. We're going to go through and we're going to see if the children contain the name of this thing. So rule.children. So we can say name in, so return rule if. So if I call parents on, say, this first rule, or maybe the last dotted black bag, if I want to call parents for this dotted black bag rule, so dotted black should return some rules for me. And we're not, that's just going to return it directly. Parents, or we'll just say ret equals loop. So ret push, and then rule if name and rule children. And then we're going to return ret. So I'm going to grab this last rule. So rules, and then rules dot length -1. So this is giving me this last name. This is dotted black bag equals, and then we're gonna log dot parents rules and see what this gives us back. See if it works at all. So it gives us, yeah, it gives us what we want. So this is basically, it's just filtering. Really, this is just a filter. So we could just say rules dot filter, and then rule, and then rule dot children. So what do we want? Name. There we go. That's a much easier way of writing it. If it works, maybe it doesn't. Oh yeah, because it's got to be bound. Yeah, so that gives us the same output. So this gives us the list of parent objects, and we're interested in not just parents. We're interested in all ancestors. So we're gonna need to rules. Oh yeah, this is an array. So ancestors are going to be recursive. So we're going to want to call parents, and we're going to want to call parents basically for each of the results as well. So parents for p in. So we're going to want to map these parents and call ancestors on these parents. Oops, that doesn't need to be here. And we can call p dot, and then we're gonna want to flatten these. So we could use something like underscore to flatten them, or we could just collect them in an array. I'm just gonna grab underscore since we have it already. Flatten equals require underscore, and we'll flatten that p dot. So this is going to give us parent dot parents, and call that with rules. So in theory, what this is going to do is this is just going to flatten everything. All right, so let's give that a try. It's angry about this. Unexpected ancestors rules equals. Okay, and I'm not calling it, so of course nothing's different. So let's call ancestors, and this is giving us an empty array. Interesting. Okay, so definitely shouldn't be giving us an empty array. I guess what we want to do is, we want to include the parents in the ancestors as well. So we want, okay, so let's let's grab that, and we'll just fill that with the parents, and then we'll say for p in parents, ret push p dot. I guess we want to yeah, ancestors, and we're gonna then flatten the return value, flatten ret. So let's see what this does. Still nothing. Okay, so this should be giving us something. So let's log ret here and see what it's giving us. It's still giving us nothing. So, oh, I'm not calling it with rules, that's why. And then rules for p in, I guess we're gonna already have those in ret. Okay, cool. So yeah, this is giving us, and this is a great time to use a set, I guess, rather than, so set equals new set, and we're going to do parents rules. So instead of return, we're gonna create a set, and we're gonna say set add, and then can we flatten a set, or does flatten ret is not just, yeah, for p and set. I don't know if we can flatten a set, maybe not. Let's log set here. So this is our set. Okay. I guess what we could do is we could create an object, and just use the names to map them. Okay, so p ancestors rules for p and set. So was it set? Can you add a set to another set? Set add JavaScript. Let's find out. Set prototype add. Let's log my set. Set has set for each values. Yeah. Script add set to set. Merge sets. Yeah, this is what I want to do. Set sets. Okay. I guess I can add it to an array, and I can just create a set out of the rather than having to do unique or whatever. Yeah, what do I want to do here? So we're getting these ancestors here, and then when I go, I guess what I'm curious about for parent and set, I wanna know what ancestors here is resolving. So I'm gonna log that and see and remove this log. Whoops. So this is giving me nothing. And I feel like I should have, yeah, for p, I don't know where p came from. Is that a rule? Oh, that's the parent. Okay, so let's log p. Oh, that's interesting. So I do have a set here. Interesting. Is it this flatten set that is fucking me up? Yeah, maybe flatten is messing me up. I think that might be the case. So set. So this is just gonna be a set that contains other sets. Set add p for, or set add object for object in. So let's see what this gives us. No, it's still giving us, well, we're logging 2 sets. So, okay. So this is still giving us just a set with 2 names. So dark olive bag, vibrant plum bag. Are these not contained in anything else? Vibrant plum. No, they're contained in shiny gold. So, I mean, we should at least be getting shiny gold bags for P in set. Yeah. Okay, well, let's remove the set and we'll keep the flatten. So keep calling this return. So this will give us an array back. For parent and return value. All right, so it's giving us some of these. Okay, ret.add is not a function. Ret.push. I guess what we could do is we could say ret equals ret, and like that. And then we can combine them. For P in ret. And read property ancestors of undefined. On line. Oh, interesting. P is undefined here. This would be, so flatten would go here, and except we're not needing to do that anymore. So for P in ret, why is that undefined? Unique. So I guess we'll also pull out compact from underscore, and we'll compact those. And it's still undefined. Cannot read ancestors of undefined. So p.ancestors rules. Or is it here? Oops. Maybe it's that it's not liking. No, it's definitely on line 53. So what is this? Yeah, this is going to push that problem to the next thing. Let's log p. Let's log ret first of all. See what we got. So we've got an array, got another array. Oh, I see. It's breaking down somewhere. So let's return unless ret.length. It's still not liking that. Can I read property ancestors of undefined? Ancestors of undefined. So why are you undefined? Log. Well, let's try that. Catch. Log p or log ret. Okay. And log oops. And find oops. Oops. So it's giving us an array of rules. So is it because we need to flatten? No. It's still giving us an array of rules. So parents rules, and then this gives us ancestors. Oh. Is it because of that? Yeah, that's it. Okay, it's because I wasn't exploding this into the array comprehension. Okay, well, let's see if this still works. Okay, so here we go. We got a lot of rules, and what we probably want to do is we want to eventually make a set of these. So flatten, I guess we can just flatten unique. Unique. Wow. Unique. This is taking quite a long time. Unique. I don't think we need to flatten actually anymore. So we don't need flatten, we don't need compact anymore. I'm gonna remove them. We just need to unique them. Okay. So what do we have here? We've got a unique set of bags. Okay. Let's see if it's upsetting that I have to pass the rules to these methods. That's kind of counterintuitive to me, but yeah, whatever. Okay, so we've got this test input and we want to assert the number of bags. So a bright white bag, which can hold your shiny, so this would be 4. So what we want to do is we want to look for our shiny gold bag and see how many ancestors there are. So shiny gold bag. So this is what we're looking for. And we're just actually going to find ancestors.length, I think. So rule, we want to find a rule. Okay, so our rule, we just want to find. Does JavaScript have find name? I think it does. Rule.name is, oops, shiny gold bag. Let's find out. Let's get rid of these. Yeah, okay. So let's just make this a method. Find bag. Name. Okay, rules. Name is name. So find bag, it's going to become find bag. Okay. So this is the bag that we're looking for. Good, we still got it. And we want to find ancestors.length. Rules.length. And it's angry. Ancestors rules. Well, let's find out what ancestors. Okay. Dot length. Oh, okay. I just misspelled it. Oh, it's a function. Whoops, it's not a function. So for we want to assert 4 is that. God, this is really upsetting to me that we're passing rules around all over the place. I feel like maybe what we should do is we should attach the set, like the bag set somehow to each of the bags, so it can just look in its own bag set, or yeah, I mean that would be better. Let's just make this work and then we'll refactor it. Okay, so yeah, so this is 4. Okay, so that, I mean that's that, and then get your puzzle input. Let's see if the puzzle input works, and if the puzzle input works, then we can look at what to do next. So the puzzle input is your shiny gold bag. Okay, so whoops, input.coffee and modula exports. Okay, don't need that anymore. So basically I'm going to do all of this again down here, except, okay, so rules, and then I'm going to grab input equals require. I'm really not happy with how this is turning out code-wise. Definitely going to have to, and then we're going to log 121 is what we've got. Okay, so really like to refactor this before we do much else. That's the right answer. Yay! Continue to part 2. Okay, so this is correct, but yeah, I really hate it. I hate everything about this. So what can we do? We could pass in a set, a bag set, or I don't know, what's a set of bags called? I don't know, a cargo container. Let's just call it a bag set, or I guess a rule set. Rules is fine. Okay, so let's pass rules into the constructor so they can all have a reference to their own internal rules. So when I parse something, parse a rule, I want to add this to, I want to tell it to use rules. And then, so where am I parsing it? I'm parsing it here, rules, okay. And then all of the, where I'm passing the rules in, I won't need to do that anymore because I can just look at this dot rules instead, parents. So I don't need to even call parents with rules anymore because parents already knows about the rules. Don't need to call ancestors with the rules anymore because ancestors knows about the rules. And find bag, I guess I can make find bag like here, find bag, because it can just find, oh no, see, it's, I still need the rules for find bag. That's super annoying, but maybe we can fix that later. So okay, we'll parse rules. Okay, so find bag rules. Rules, let's see if I got all the rules. Rules, find bag, ancestors rules, we don't need that anymore. Okay, so let's see if this still works. It does not. Null is not iterable, cannot read symbol iterator. Line 56. Parse. Object is null. Object null is not iterable. So I'm not passing in the right thing. So this rule here, this would be, I guess we should call this line. And that's not gonna fix it. Rules push. Let's see if we put that on a different line, if that gives it object. No, it doesn't do anything. So we're passing in this array, and as rules, children equals children filter name isn't another bag, and then we're creating a new rules name children. Okay, so what do we do? Object is not iterable, so this is line 56. Object is not iterable. Is it line that it's not liking anymore? Log line match. Let's find out. Yeah, it's giving us null here. Is that because is it in here? Let's. Yeah, that's where it's giving us this problem because it's saying something in here not matching. That's interesting. Anyway, we'll figure that out later. So, okay, so we're sorting for, so this is correct, and this is working. So we've refactored that properly. Oh yeah, it's because it's, right, it was supposed to be rules. There we go. So this is still gross. It's still giving us the right answer. I like it a little bit more now that we don't have to pass rules into every method. It understands that it's part of a set of rules. I wonder if we could just, we could add it to the set of rules in the constructor rather than having to push it here. I kind of like that. Rules.push self. And then we can just parse these. And let's just get rid of this run section for right now. Yeah, okay, so that's still working. Okay. So that we can process the input and we can get back rules. So we can say process. So make rules or parse rules. And then this can be text. And this is going to give us rules back. So we can say here equals parse rules input. Yep, still working. Okay, and then find bag is still something that takes in rules and returns a bag. So we want to find a rule where the rule name is name. So I mean, this is better. It's still annoying that we have to find the bag. But you know what, like, I don't know. I don't think it's going to get much. I don't think it's going to get much better than this. At least we're not doing that anymore. Okay, so we've got the new input, and then we want to find this bag again with the rules, and then we can log the length. Where am I logging? Logging the length. I'm also logging something else right up here, line match. Okay, so that's giving us 4 input. Require input. Why is this? Oh, right. So something else. Something was breaking somewhere, wasn't it? So rules, parse rules, require input. So shiny gold bag and log shiny gold bag ancestors.length. So this should be giving us 121, and it is not. So that's very confusing to me because we're doing parse rules require input, parse rules. Okay, so for some reason, these rules in here, oh, for line and input, that's the problem. I always do this, is refactor and then forget to check all the things. So this should be text. Okay, so now we got 121. Okay, so pretty happy with part 1. As happy as I'm gonna get. So let's move on to part 2. So this is probably where the number of bags is gonna come in, and we actually haven't accommodated for that. It's getting pretty expensive to fly these days, not because of ticket prices, but because of the ridiculous number of bags you need to buy. Okay, that's fair. Consider again your shiny gold bag and the rules from the above example. So faded blue bags contain 0 other bags. Dotted black bag contain 0 other bags. Vibrant, okay, 11. Other bags, 5. Okay, so a single shiny gold bag must contain 1 dark olive bag and the 7 bags within it, plus 2 vibrant plug bags and the 11 bags within each of those. Of course, the actual rules have a small chance of going several levels deeper than this. Be sure to count all of the bags, even if nesting becomes topologically impractical. Okay. A shiny gold bag must contain 126 other bags. And that's what we have already, right? Like a shiny gold bag. We have this in the previous input. So it should be, so we'll be able to test with this, I guess. A single shiny gold bag must contain, this is really the only assertion I think that we're going to have to make, is the 126 is the number of bags that it contains. Okay, so let's grab these and we'll move on to part 2. Coffee. All right. All right, and oops, there we go. And this is going to be part 2. Guess we should take the question with it. Why is this so difficult? There we go. Keyboard, please. Paste. All right, part 2. All right. It's plain text. And the example, it's just a plain text block. Okay, so we've still got our bags, but we're not capturing the number. What we're gonna wanna do is we're gonna wanna create a digit space. Let's see what this looks like. Going back to here. Okay. Let's just, there we go. Whoops. So first of all, let's get that out of the way, and let's log. I'm just going to grab one of the lines from part 1. How about this one? That'll work. All right, so let's see what this gives us. 3 bright white, 4. Yeah, okay. So now it's giving us that, and we're going to want to call so name and children equals, yeah, match. Right, this is just giving us the matches. Then what we actually want to do is we want to pull these, numbers out. Okay, so this is going to give us that. And then I guess when I take in the name, maybe what I can do is I can split it into the number. Yeah. This is going to be a pain because I'm actually just matching on the text of the names. So I don't necessarily want to do this. So if I include the number as part of the name, then anything with a different number is going to be treated as the same name. So I'm gonna have to pull out the number, and then I'm gonna have to basically deconstruct it further into, well, even the children. I'm gonna have to deconstruct both the name. I guess the name is never gonna change, right? The name is dark orange bag, and then it's the children that will have the number. So it's just the children that will have the number. So, oh, this is interesting. I don't actually need, Maybe I'll have to split this into two. Name equals line match, and it's not global because it's always going to be the first. Oops. So this is going to be the first, and then what we're going to want is we're going to want something with the number of children. So this can be children equals line match, and then I've lost my decimal plus space. So log name children. So let's see what we get. Log. Oh, I'm not parsing anything. But still, name, and then log children, and let's do rule parse. Rule parse. Oops. Hi. There we go. So it's angry, name null. So it's not liking this. So rule parse. Oh, rules. Yeah. Right. Okay. So bright white bag. Name is dark orange bag. So dark orange. And then children 3 bright white. So the children. So the way we have children here is going to be. It's going to have to change. So currently we're just storing it as an array of strings. And what we're going to have to do is we're going to have to store it as something else, maybe like an object of keys. Keys with a number. So it's going to be like that. And then we're doing with children here. So parents, where name in our children dot keys, or is it object dot keys? Yeah. Okay, so do I have children anywhere? Children. Okay. So children. So let's make the new children object. So children equals that, and then we can say for in child in children. Say 1. Actually, I think what we can do is we can just yeah, children 1. This can be child O equals child 1, and then name isn't no other bag. So we're also going to have to do this filtering. Yeah, this did not work out well for us. And then let's log ch, and then let's just not do these things. Okay, let's see if this works. Okay, so name ch 3 undefined br. Okay, well that is not working how I thought it would. So let's say children line match. Oh, this should be global. Long children. Oh, because we haven't parsed it. And I guess what we're gonna have to do is we're gonna have to parse this now and just say, right, we want bright white bag. Oh, yeah, okay, so this is actually not giving us bag anymore. Dark orange bag, there we go. So children, so we're gonna have to do for child in children. We are going to have to do a match on this. So we're gonna do child dot match. Yeah, basically this. And then let's log that just for now. Okay, so 4 muted yellow. So this is going to be, yeah, this is going to be children's strings. I guess we can call this child strings, just to make it, whoops, child strings. And let's get rid of this because this is not helpful. Okay, so child strings. So in child strings, okay, so we're logging that match. So what we're going to want to do is we're going to want to make children equals an object, and we're going to want to do so it's going to be the match equals that, and we're going to want to say children match, oops, 2, so this is going to be the name. In fact, what we could do is we could say underscore num name, just like that, equals that, and then this can be name equals num. And then what we'll do is we'll log children over here. Log children, undefined, undefined. Oh, this should be an array. Bright white 3, and of course this should be parse float. Okay, so bright white, muted yellow. Okay, so this is giving us the data that we want, but we still haven't accounted for this no other bag thing. So I guess what we can do is we can filter out, oh right, and this is giving us, right, so it should be bright white bag. So we want to filter out anything that isn't no other bag. So in child strings, so what we can do is we can say unless name is no other bag, and then that won't give us no other bags. And then we just won't have that included in the children. Okay, so okay, so new at rules. Well, I guess no other bag wouldn't probably match because there's no number. Anyway, whatever. We'll filter it out just in case. So name and then children. So we got this. Still logging the name. Oh, that's not the name that we want, is that? We want name match. We want name. There we go. Okay. So we're going to parse the input. This is going to blow up. Input is not defined. Oh, because we never copied the input over from the first time. Here we go. Input. So this is our previous input. We'll put it down here. Cannot read property length of null on line 58. Child strings, interesting. Line match. So if we can try that. Okay, so let's find bag rules. See if assert for. Okay, so this is still working. I wonder what rules looks like. Let's take a look. Log rules. So rules. Okay, so children, bit of blue bag, name. Okay. And sometimes there's no children. Okay, so this is fine. What is this log? We don't care about that anymore. We don't care about this anymore. Okay, parse rules, input. So now we've got this structure, and what we want to be able to do is we want to count the number of bags. Count child bags. And basically what we want to do is we want to loop over the children and we want them to tell us how many child bags that they have, and vice versa, or etc. So count child bags, and we'll sum all that up. It'll be similar to what we were doing with ancestors here. Whoops. And except for the fact that we're actually just going to be counting bags. So the number of bags we have is children. So object dot values children, and we want to sum those. And right, still no array sum in JavaScript, so we want to do object of values children, and let's add a 0 in here just so we can I guess we don't need to do that actually. It's children, because what we're gonna do is we're gonna pass this into reduce, and memo equals 0 val, and we'll just say memo plus val. So count child bags. So we're gonna have the immediate count. So this is the top level count. So this is immediate count equals that count. And then what we're gonna do is we are going to map over, so instead of object values, we're gonna do object dot keys children for child name equals, or in object keys children. What we're going to do is we're going to do basically the same thing. We're going to find the child bag, and we're going to count child bags on that child. So how do we do that? That was find bag rules. So we still need to pass rules in, and we're going to with chname. So child equals that, and then we can probably abstract this into something as well, and then we'll call ch dot count child bags. Count plus equals, and then count. So let's try this, count child bags. So what did we want to assert? We wanted to assert that 126. So assert 26 is, and no, something is blowing up. Children is not defined on line 53. Oh, not children. Children. Okay, another problem. Reduce of empty array with no initial value. Yeah, so this is going to be an empty array. So let's put this what I was thinking. Let's throw, whoops, not there. So object values. Oh yeah, it's going to be here that we want to do it. So that and object values children. We're going to reduce that. It's still not angry. It's still angry about that. So false equals true. So let's see what we are getting back for this value. So let's remove the log rules. So count log count child bags, and we are getting 21 instead of 121. Okay. So 21 instead of 121. So that's interesting. So let's see now. For child name and object keys children. Find bag rules. Count child bags. So this should give us the total number. One thing we can do is we can pull out sum. And that's going to be like array. Arguments. All right. And then sum, where was I using sum? So it's still angry. Reduce is not a function. Okay, I'm just gonna back out of this. I don't need to add this to my list of things to worry about. Okay, so what was this error that it was giving us? False equals true, so we're getting 21 instead of 121. So why are we doing that? So count child, it's probably because we're failing to add something here. So log count, and then for child name, child, and then count plus equals count child bags. Okay, so log finding and then has this many child bags. Okay, mark all of the bag. Dotted black bag has 0 bags, has 0 bags, has 11 bags, and then, okay. So am I overriding something here? Count child bags. Let's see. Count equals that. Okay, so log count. So that's where the count is now. I guess we should count log name. Okay, so shiny gold black bag count finding dark olive bag. Okay. Okay. And then down here, now has, whoops, faded blue bag, count 0. Now has count 21. Okay, so we had 21, and then, oh, I think I'm just running this twice. Is that what it's? Yeah. Okay. Okay, so now has 21. So what happened here? So we had 3 directly, then dark olive bag had 7, and then dark olive bag would have bunch of these. Faded blue bag. Faded blue bag had 0 bags. Okay. Dotted black bag. Dark olive bag now has count 7. So dark olive bag. And dark olive bag has, what does it have in it? Dark olive bag. 3 faded blue bags, 4 dotted black. Faded blue and dotted black. Okay, so it has 7. That's correct. So dark olive now has 7. Okay, so we add the 7, and then shiny gold bag, 1 dark olive, and 2 vibrant plum. 2 vibrant plum. Oh, interesting. So one of the things we're not doing is we're not looping over vibrant plum 2 times. So maybe that's the problem. Okay, so let's do that. So, because we're counting the contents of a vibrant plum, but we're not counting the number of vibrant plums. So, okay, so for so name and num of children. So we want to do num times, we can just multiply that. And that gives us 32, but that's not the right answer either. So so for child name, that bags. So now we're at 32, but 32 is still a far cry from 126, unless I'm misreading the question. Okay, so in this example, a single shiny gold bag must contain, so maybe this is shiny gold bag contains 2 dark red contain 2 dark orange, 2 dark yellow. So this has 126 other bags. So maybe 32 is the correct. Contains 0 other bags. So we're actually going on our old input. But that's, consider again your shiny gold bag and the rules from the above example. Okay, now so these, so again, a single shiny gold bag must contain 1 dark olive bag and the 7 bags within it. I wonder if these examples are just confusing. Equals, okay, so look at this. So single shiny gold bag must contain 1 dark olive bag, okay, equals 32 bags. Okay, so and that's the answer that we're getting. We're getting 32. Of course, the level deeper. So so this is a different example that wants us to assert 126. It's this one wants us to assert 32, which is what we're getting. So we can, okay. So cool, we still got this assert about the length. Okay, we can remove a bunch of these logs now. So this is what we're getting. Okay, so this CH can just be find the bag. and then count child bags. Count child bags is kind of annoying. Num child bags. Let's try that. Okay, and can log that. So this is going to give us the number of immediate children and then their number of children. Okay. Yeah, 32. And we're still logging something somewhere here. Okay, cool. So these assertions are working. So let's pull in the rules and whoops. And let's log numchild bags. Let's see what we get. 3805. So let's see if that's the answer. And if it is, then we can clean this up. Call it a day. Answer. That's the right answer. Okay, cool. We got one gold star. So day 2 definitely got a lot more complicated than I was expecting it to. But through a lot of trial and error. I don't like how we are reusing these patterns all over the place. Definitely not enjoying that. Okay, let's take a look. Let's just take a quick look at day 1. It was definitely a bit confusing that the input for day, or what we were being asked was a little bit weird. So it seemed like this was the assertion that we wanted to make, but that's another example, and that was confusing to me. So definitely up here, this is the assertion that we want to make was, hey, with your gold bag, you want to assert that it has 32 contained within it. So definitely this was a red herring to me. I read this wrong, and I looked at this being the assertion. A single gold bag should have 126 other bags, but in this example, and this isn't given in the same format as our input here. Is that contain? I guess it is. I guess we could potentially assert that input as well. So I mean, let's give that a try. Let's input equals. We'll just overwrite the input here. So maybe this is what we should have done all along. We should have brought this new input in and then asserted, so 126. Yeah, this is what we should have been doing the whole time, I guess, is bringing in the new input so we don't have this old input anymore. And then asserting that that's true. So let's update this. So this input, we don't need to pull in the input twice. So this is absolutely my fault for not paying attention, as usual. Should have, whoops, read the question maybe a little bit more carefully, and that would have been much better. Okay, cool. So now the assertion is true for what we were expecting, and we only have one copy of the input. That's a good indicator, I think, to me, that we're doing the right thing, is if we don't have to copy input from a previous example. Okay, so let's take a look at what we got here. Okay, so here we are passing the rules in. Okay, we did that. Name, children. These children, we didn't parse out the number with the children in the original version, and that kind of gave us more work in part 2. Probably could have seen that coming. But that was okay. That works. Find bag. I'm not a big fan of having these dangling methods here, like find bag with rules. This is kind of a code smell to me. It's because you have to split this up into two things. You need to get the rules, and then you need to find the bag, and then you need to call the things on it. But I think for this case, it's okay. Ancestors, I feel like there's probably a smarter way we can do this as well. Like we can just add your parents and the ancestor. I guess that's exactly sort of what we're doing, is we're adding your parents and each parent's ancestors together. It just kind of looks ugly. It's probably because I've chosen bad names for things. Here as well. So we've got our rules, our name, and our children is now an object. And the parents is the same. I don't think, do we even care about parents or ancestors anymore? I don't think we do. I don't think they affect anything anymore. But may as well leave it in since it's from before. I guess we'll just leave it in commented out for now. Num child bags, parse. This is where parse got more interesting. And then find bag we still use, parse rules we still use, parse rules, find bag. Yeah. So we don't need parents or ancestors anymore in part 2, but I'm gonna leave it. I'm gonna leave it here because it was just copied over. Yeah, whatever. It's good. So we made that misstep with not asserting the right thing, or asserting the right value against the wrong input, and then run. That worked. Okay. Yeah, that was okay. I'm not super thrilled with how that went, but we got the right answer at the end of the day, and it's okay. I might sit on this for a while and think about it, and then come back to it. I plan on doing that with a couple of the other days too. Like what was day 5, binary boarding. So this day, I'm really not happy with how we solved this in retrospect either. Just because, like, at the end of the day, I mean, the seat is just a binary representation of this whole string. So, I mean, did we need the calls and the rows at all? Like, do we need to calculate these things, or could we have just skipped to it? Yeah, and maybe I'll do some other videos where we just refactor those down. But for now, let's just commit this. So this was day 7. Whoops, day 7. Okay, well, that was fun, and looking forward to tomorrow. But for now, guess we will stop streaming. So see you tomorrow.